Hi guys, welcome to another quick revision video. Today we're looking at inequalities. We have been asked to draw the lines x equals 2, y equals 3, x plus y equals 6, and to shade the region that satisfies the given inequalities, x plus y less than or equals 6, y greater than or equal to 3, and x greater than or equals to 2. Now, even if you are just given this uh, form of the question without the first part that asks you to draw the straight lines, whenever you are given a set of inequalities and asked to shade the region or to find the region that satisfies them, the first thing you need to do is to draw these straight lines. Okay, so in fact, you can see in this illustration here, we have an inequality where we have shaded the region where y is greater than x. Again, the first thing we did here is to draw the line y equals x, okay, along this broken line. And that's also something to note, right? Anytime you have these inequalities, these are called strict inequalities, you draw the lines as dotted lines, okay, the broken line. If you have these inclusive inequalities, you draw a solid line, okay? So first we draw the straight line. We draw it as a broken line because these are strict inequalities, right? So we draw that. In this case, you can see that along this line, the values of x are equal to the values of y. So if x is 2 here, then y is also 2 here. Okay, and then we proceed to shade the region that is required. So within this region, the values of y are always greater than the values of x. If you take, say, a point like this one here, we already said this is a 2. If you trace the x value, we say this is minus 1, minus 2, it doesn't matter really. We can see that in this case, the value of y is 2. It is greater than minus 2. So it satisfies our inequality. So that's why this point is within the shaded region where y is greater than x. Okay, so those are important things to keep in mind. Now, the next thing we do, let's dive into the problem. So yeah, so the first thing we are going to do is to draw the straight lines, and then we'll consider our inequalities. Right? Let me bring up a ruler. You need a graph paper to follow with this. So let me just, this is going to be a little wobbly. For the line x plus y equals 6, what you need to think about is that the values of x and y, they have to sum to 6. Right? So in the extreme case, the highest value has to be 6. So if, say, x is 0, then y has to be 6 for um, for this equality to hold, for it to be equal to 6, right? So if we consider the point at the point where we have x is 0, y is 6, x is 0 here, and y is 6, it will be this point here, right? So that's the one extreme. The other extreme is where we have where y is 0. If y is 0, for this equality to hold, for us to have 6, then x has to be 6. So in that case, if y is 0 here, then x has to be 6. But along that line, all combinations of x and y have to be equal to 6. Okay, so let's just draw that line here. Oh, let me see if I can. Okay, that works. So we can now draw our line. So this is the line we're looking for. It's the line where x plus y x plus y equals 6. Okay, it's this line. Then we draw the other line, y equals 3. Remember I said it's a horizontal line that is parallel to the x-axis. So here is the point where y equals 3. So let's draw a line. So that is the line y equals 3. Okay, it's just a horizontal line. And then the last one, let's change the color, let's pick red. We draw another line where x equals 2. We see that it's this point down here, x equals 2. So let's pivot this line. It's this point. Okay, so there we go. Let's just draw a straight line. There we go. Okay. So this line is x equals 2. And previously, our line was... Oh, okay, we already noted that. Okay, so that's the first thing. We have drawn straight lines, right? Now, we have been asked to shade the region that satisfies the inequalities. If the question doesn't ask you to shade that region, usually textbooks would recommend that you shade the region that is not required. Please keep this in mind, okay? And the reason why is that it's easy for you to isolate the region that satisfies all of these inequalities. Now, in fact, if you want to save time, you would just basically shade this region because it will be that region. For this, within this region, the values of x plus y have to be 6 or less than 6. Okay, that's what the key thing you need to keep in mind. But I'll just go through the general case, which is slightly messier. But yeah, and the coordinates of the points that are bounding that region would be these coordinates here. Okay, for x plus y less than equal to 6, what we're looking for is points that are below the line. Okay, points that are below the line for this one. So let's take the blue color. We need points that are below this line. If you don't know which points you need, just you take a reference point to test. Usually it's the point 0, 0, where x is 0 and y is 0. Now, if you put those in our x plus y equals x plus y less than equal to 6, you would have 0 plus 0. That is definitely 0 is less than 6. So this point 0, 0 is within the region that we're supposed to shade. Okay, so we are right to shade this side of the line. Okay, so that's the first one. And then for y greater than or equal to 3, we can see that the line y equals to 3, the points that are above this or equal to it would be on this side. And then finally, for the values of x greater than or equal to 2, we know that along this line, all values of x are equal to 2, but we're shading the rest of the case where they are also greater than 2. So this is why I said it is this region here that satisfies all these inequalities. So now let's just write down the coordinates of those points. This point here, where x equals 2 and y equals 4, satisfies our inequalities. For example, if you put 2 for x and 4 for y, for example, that is equal to 6. It satisfies our inequality, right? Because they say x plus y have to be equal to 6 or less. So therefore, the point 2, 4 is part of our points that satisfy the inequalities. And the next one, where we have this point here, where we have x equals 2 and y equals 3. Similarly, if you do the same, it checks out for all of our inequalities. So x2, y3, and finally, the point where we have x3 and y3. Okay, so point 3, comma 3. Within this region, if we take a point, for example, here, it also satisfies all of these three inequalities. Okay, I hope you found this useful. See you on the next one.